Here again. Today we're going to be talking about finding probability, and we're doing lesson 20-2, investigating chance processes. So let's first unpack our learning targets here. Today we're going to be collecting data about chance processes in a frequency table or a list. And then we're going to determine the probabilities for outcomes in a probability experiment. So real quick, let's do this. Let's take a look at this first example here. It says use a paperclip to spin the spinner 20 times. So we're going to use a paperclip. So if you don't have a paperclip, get a paperclip, and we're going to spin this spinner 20 times. So what you're going to do is you're going to put your pencil right here on this dot. Your paperclip is going to be on, and you're going to flick the paperclip with your finger and spin it around until it lands. If it lands on a line, just go ahead and spin it again. And then every spin that you do up through 1 through 20, you're going to record your results. So if you start here, flick it, go around, and let's say you land on the 1 first, then you're going to put a 1 there. Let's say you spin it again and it goes around, and you land on a 4 this time, you'll put a 4 here. And you're going to keep doing that 20 times. Then at the end, you're going to put your total number of 1s that you landed on, so you'll add them all up, or count how many total you have, you'll put them here. How many 2s, how many 3s, how many 4s. You're going to do that 20 times. Now look at this math term down here. This is what we call a probability experiment, which is the process of observing an outcome when there's chance involved. This means that before you do the experiment, you can't be sure what the outcome will be. Now we can take a good guess because if you look, this spinner is divided equally into 4 equal parts. So the number 1 has a 1 in 4 chance of landing. The number 2 also has a 1 in 4 chance of landing, and the number 3 has a 1 in 4 chance of landing. So each one has a 25% chance, theoretically, of landing on that number. However, this is a probability experiment, so just because theoretically each number should land on it 1/4 of the time or 25% of the time doesn't mean that if you do this experiment 20 times, it's going to be perfect and each one's going to have 5. Because if it was perfect, each one would be 5, 5, and 5. But that's not always going to be the case. It could be the case, but usually it's not going to be. What I want you to do now is I want you to go ahead and try this probability experiment on your own. Take your paperclip and spin it 20 times, record your results in the table, and see how close to 1/4 or 5555 you get. Press pause and do that now. All right, next we have 3 spinners. For the spinners below, find the probabilities. We're going to write our answers as a fraction. So this first spinner here, each piece, 1, 2, 3, 4, 5. There's 6 pieces or 6 segments or parts of this spinner. So this one means the probability of landing on a 2. Well, how many 2s are there? There's 1, 2 here. So as a fraction, there's 1 possibility out of the total number. So this is the numerator is always the number of successful chances or the number of success opportunities there are. So there's only 1, 2, so it's 1 out of how many total? 1, 2, 3, 4, 5, 6. There's 6 total, so you have a 1 in 6 chance of landing on a 2. For the probability of landing on a 5, let's see. Hold on, there's no 5s at all, so that's just a 0. Probability of landing on a 6, let's see, there's 1, 2 6s here. Okay, so we have 2 out of 6. Well, that's a fraction that can be reduced. That's 1/3. Probability of landing on an 8. In this case, there's 1, 2, 3 8s. There's 3 8s out of 6 total. That can also be reduced to a half or 50%. And then finally, an even number. Let's see how many of these are even numbers. 1, 2, 3, 4, 5. All 6 of these are even numbers. So 6 out of 6, which also reduces, and that just reduces to 1. So that's the probability of landing on all of these here. I want you to go ahead and do the same thing for number 2 and number 3 on your own. For number 2, this is saying the probability of spinning this spinner and landing on snake is this first example here. So I'll do that one with you. So there's only one snake out of, again, 6 total, so that's a 1/6. I want you to do the rest of these on your own, so press pause now and do number 2 and number 3 on your own. Now, for number 3, 4, and 5, misnumber those. It should be 4, 5, 6. But for this first one here, we have a weird kind of spinner where it's not all divided equally. And for this, it says use the spinners below to find the probabilities listed. We're going to write our answers as fractions and as decimals in this case. So for the first one, the probability of landing on a 1. So we have to kind of think strategically about this. Notice that 1 takes up it takes up half of this square. You can see because it's cut diagonally, it takes up half of the square. So that one's an easy one. We can know that's 1/2, and as a decimal, that's 0.5. So that first one's pretty straightforward, pretty simple. The probability of landing on a 2. Notice 2 is here. Notice how this 2 piece is smaller than at least our number 1. So we need to cut all of these to be the same shape or the same size as 2. So you can see 3 is there, so we'll cut this one. Then notice that. We'll cut this, and then we need to cut 1 there. So now we've just divided this to be equal parts as this 2. So now we have 1, 2, 3, 4, 5, 6, 7, 8 total pieces, and only one of them has a 2 in it, because really, this is a 1, this is a 1, this is a 1, this is a 1, this is a 4, this is a 4, and then that one here is a 3. So there's only one piece that is a 2, so that's 2, sorry, not 2, there's only 1, 2. There's one piece that is a 2 out of 8 total. And so this is where you might need to grab a calculator to figure this out using a calculator, or you can do your long division. Either way, whichever one works, calculator would be fine. But if you do 1 divided by 8, you would get 0.125, or that's like 12.5% if you change that to a percentage. Let's do the same thing for number 3. So now it's a lot easier. Now that we've divided them all into equal parts into the smallest pieces. Again, there's only 1 3 here. So again, it's 1 out of 8 total pieces. And again, as a decimal, that would be 1.25 or 12.5%. And then finally, how many of them have 4s? Well, there's 2 pieces that have 4s. 1, 2 out of 8 total. We need to reduce that fraction. 2 8s can be reduced to 1/4. Hopefully you know 1/4 as a decimal is 0.25. I want you to do number 4 and number 5 on your own. I'll go ahead and give you just a little bit of a hint here, because you're going to want to divide this into parts that are similar to like this piece number 2 and piece number 4. So we're going to need to cut this. So I'll go ahead and cut it diagonally. And then you're going to need to cut it again here, so that now all the parts have equal size that are matching this 2 and this 4. So go ahead now and label each one of these to find the probability that you can spin the spinner and land on a 1, spin the spinner 2, 3, and 4. Please do number 4 and number 5 on your own. Press pause. For 6, 7, and 8 here, now we're going to use the blank spinner, and we're going to design our own spinner from the probabilities that are listed. All right. So in this case, probability that we land on a 1. We want to make this spinner have a 25% chance, or as a fraction, it's much easier to write this as a fraction, to have a 1 in 4 chance of landing on a 1. So we know let's divide this into 4 pieces. Boom. And we'll put a 1 there. Perfect. Now also notice the probability of landing on a 4 is also 1/4, as is a 5. These are all 3 1/4. So there's a 1, there's a 4, and there's a 5 that all have 1/4 chance of landing on it. Now 2 and 3 are a little bit different here, because now this is 12.5%. And if you'll remember back from up top, 1/8 is 12.5%. So this really means 1/8, as does this, 1/8. So what we're going to do is we're going to divide this leftover piece that we have into two pieces, and then we're going to make one of them 2 and one of them 3. So now we have all equal parts where it all ends. Go ahead and do the same thing for number 7. For number 7, it's probably going to be easiest if you have these all have common denominators using a total of 6 total pieces. So divide this up into 6 total pieces and then design your own spinner yourself. Same thing for number 8. And then finally, for number 9 on your own, you're going to do those. So press pause and complete the rest of this worksheet on your own. Thanks, guys. Work hard. Good luck.